exponential functions here, given a function such as y is equal to e to the power x, the general form of the derivative is dy over dx being equal to e to the power u by du over dx, right? So the caveat here is that if you differentiate e to the power x, you are going to get e to the power x. So first of all, write the function as it is. Don't do anything to that function. Then you multiply it by the differential of that function. How do you get a function I'm talking about? Or what are you going to represent as your u? If you cover this e, what is left on top of it is the x, that is the function. Or what is on top of the x here, the e here, which is x, is your u. So let u be equal to x, right? The differential of x is du over dx. That will give you 1, right? So write the function as it is, i.e. e to the power x multiplied by the differential of x. That will give you 1. E to the power x by 1 gives you e to the power x. That's why I was saying that the differential of this e to the power x gives you the same thing, right? Given a function such as 2x to the base 2, the general form of derivative is d log u to the base b dx is equal to 1 over ln of b multiplying u times du over dx. Let's look at this explanation here as to this logarithm approach. So log x to the base 2 is equal to y, means that this base of 2 raised to the power y should give you x. So 2 to the base, or 2 to the power 2 to the power y should be equal to x. An example is that when you have log 8 to the base 2 is equal to 3. Simply is because, or it simply means that this base of 2 raised to the power 3 here, or raised to the power what number, should give you 8. Remember, 2 raised to the power 3 is equal to 8. Same here, log 1 base 2 is that what number raised to this power, what number are you going to put it on top of this 2? Or 2 raised to the power what number is going to give you 1? Remember, 2 raised to the power 0 is equal to 1, right? Because any number raised to the power 0 is 1. Same applies to this last one over here. Now, this is how you deal with the logarithms. All right, let's look at an example under the exponential function. This is what I just explained. U is what is on top of the e, so u is equal to x. Du over dx, the differential of x here is 1. So to find the dy over dx simply means that keep the function as it is, because if you differentiate, you get the same thing. Then you multiply it by the differential of what is on top, i.e. x, which is equal to what? 1. E to the power x times 1 gives you e to the power x. Find y prime if y is equal to this, e to the power x squared plus 1 all squared. Keep the function as it is, right? Dy over dx, keep the function as it is, right? Multiplied by a differential of what is on top of the e, which is x squared plus 1 all squared, becomes the function, or becomes our u. So bring the power in front of the function, reduce the power of 2 by 1, then you multiply it by the differential of what's in the bracket. Differential of x squared plus 1 gives you 2x. So keep the function here again. You multiply 2 by 2x, that will give you 4x into bracket x squared plus 1, right? So this is how you go about the exponential functions. Let's look at where we have to apply what we've learned here in the business sense, or under what is called economics, right? So where we have elasticity of demand, or elasticity, we'll say that is a degree of responsiveness, right, to a change in the quantity of a commodity with respect to the change in the price of that commodity, right? So we'll say it is change in quantity over the change in price, where Q is the quantity and P is equal to the price. So the change in Q, which is our quantity, is equal to dQ over Q. Change in P, which is our price, is dP over P. So what is the elasticity? It is dQ over dP multiplying, right, multiplying the P over Q. That is the elasticity. So the Q over the P. The formula is the Q over the P multiplying P over Q. When Q is expressed as a function of P, then the elasticity becomes function of price. That is the meaning of this formula over here, right? So that's the same thing you are having here as the elasticity formula. So let's look at a practical example where we are going to use this formula over here, right? So it says that the demand function for a product Q, which is quantity, is equal to P squared minus 40P plus 400, right? Where Q is greater than 0. This simply means that as a producer, say you are a manufacturer of a certain product, right? Right. So say you are a manufacturer of a certain product, you can't say that you produce negative quantity of your products, right? Always the quantity produced is greater than what zero. That's the interpretation of this thing over here. So find the point elasticity of demand right here. So to find that, we say that it is the Q over the P, change in quantity over change in price times price over quantity. So we have to find our dP over the Q, which is what? P squared minus 40P plus 400. So the Q over the P will give us what? 2P minus 40 times P. We don't know P, so P here over Q. Q has been given as this whole function you have here, right? So over P squared minus 40P plus 400. 2P minus 40P multiplies P. That gives you 2P squared minus 40P all over P squared minus 40P plus 400. Right. So a further question could be that find the point elasticity when it is equal to P is equal to what? 15. So just substitution. Wherever you see P here, you put 15. And that gives you 2 into bracket 15 squared minus 14 into bracket 15 over 15 squared minus 14 into bracket 15 plus 400. And we have our point elasticity to be negative 6. The interpretation is that a 1% change, right? So a 1% change or a 1% increase in the price of their commodity or of their product leads to a 6% decrease in the quantity demanded of that same product. Right. So if the price increases by 1%, the quantity demanded decreases by 6%. It also means that there is a negative relationship between price and quantity of that product or commodity. Thank you for this time. We'll be looking at the other sections another time. Goodbye.